you by thesis123.com. I learn and teach online.
Here's the next question, number 8. In the following circuit, the input voltage Vin is 100 sine of 100 pi t. For 100 pi RC equals 50, the average voltage across R under steady state is nearest to, okay, so we have our 4 options, 100, 31.8, 200 and 63.6. Okay, so please observe the figure given to us. Now, when the two diodes are operating, they operate only in terms of half cycle, positive half cycle of the input voltage and negative half cycle. So here they take turns because of the positive half and the negative half. So if and when the positive half cycle is going on, let's call this as D1 and we'll call this D2. Similarly, we'll call the C1 and C2, though they might have the same values of capacitance. Just to indicate exactly what is operating during half cycle, I'm putting this as denoting them as D1, D2, C1 and C2. So let's analyze what happens during the positive half cycle. Now when the positive half cycle is going on, you will see that the positive side is here. So D1 is in the forward bias state. So D1 is forward bias, D2 would be reverse bias. So now the diagram becomes, I'll draw it here. This would be open. I'll bring it down here a little bit. Okay. So this is our R. C1, C2, we have our input here. Okay, so this is open because D2 is in the reverse bias, and this is closed because D1 is in its forward bias, plus, minus. So now you will see that Vin, the voltage here Vin, appears across C1, okay, and then this gets divided to C1 and R. C2 is left out, okay. So this is during positive half cycle. So during the positive half cycle now, V0 that is calculated across R is Vin times R divided by, now we have to take the resultant of these two. So we can write it in the form of R minus jXc, where Xc is the reactance of the capacitor, okay, capacitor C1. So this is for the positive half cycle where V0 is equal to Vin into R divided by R minus jXc. Now if you will notice this equation here, we have used voltage divider formula. V0 equals Vin into R divided by R minus jXc, okay. Now the expression is 100 pi RC equals 50. So when 100 pi RC equals 50, let's find out what R is. R would be 50 divided by 100 pi C, right? Okay. So now notice what 1 divided by 100 pi C is. 100 is 2 into 50, right? Now 50 is the frequency. That indicates that 100 pi C is 2 pi Fc. 2 pi Fc. And what is 2 pi Fc? 1 divided by 2 pi Fc is Xc. So here R equals 50 Xc. I hope you understand how we have taken 100 pi RC equals 50 and written it as R is equal to 50 Xc. Okay. Now let's substitute this into R over here. So we have our formula. V naught is equal to V in into R divided by R minus JXC. Okay. So this would be V in into R. So R now we have figured out that it is 50XC divided by 50XC minus JXC. So we can now, let's substitute what Vn is. V naught is equal to 100 sine of 100 pi t into 50xc divided by 50xc minus jxc. Alright, so either way what we see here is that the magnitude of the output voltage remains as 100. This is the peak value. Focus on the peak alone. Okay, so for the positive half cycle, the peak value is mod 100. Okay, mod 100. So our peak value is 100 here. Please make note of that. Now let's look at negative half cycle. If we look at the negative half cycle, V naught of peak. Okay, take a look at what happens here in the negative half cycle. Now in the negative half cycle, D2 becomes forward biased and the input voltage is seen across C2, across the capacitance C2, and then this is split between C2 and R. So in a very similar manner, if the positive half cycle V naught is the magnitude or the peak value of 100, then for the negative half cycle we would get the magnitude as mod of minus 100. So totally V naught would be equal to the sum of both mod of 100 plus mod of minus 100, which comes to 200 volts. I hope that makes sense. So here the answer is 200 volts. So that's option C. The average voltage across R under steady state. So we calculate for the peak at positive half cycle, we calculate the peak at negative half cycle, and then the sum of both would give us the average voltage in steady state.
Thank you for watching this video. For future videos, please click here to subscribe YouTube channel. Visit our site thesis123.com for free student project or research ideas and online training. Follow us Facebook, Twitter, Google+ and Pinterest.